Okay, we just finished covering how to multiply polynomials together. And the natural, I guess, progression from there would be how do you actually go backwards, or how do you like undo multiplication, right? Because in math, we're always interested in what's the opposite operation of something, or we want to undo things. Like subtraction is opposite of addition, division is opposite of multiplication. So in this sense, we're going to be kind of dividing in a sense. But yeah, we're going to be doing a process called factoring here in this section. And factoring, just you can think about it as the opposite of multiplying something, which we just we just got through in the last section. So let's say like you're taking some number like 24, and they're saying, hey, break this down or factor it into its. A lot of times you go prime components. So prime numbers, common prime numbers that you're looking at for factoring are like 1, or well, not 1, 2 is the basic one. 2, 3, 5. Because the only thing that makes these numbers happen are 1 times 2. It's just 1 in itself are the only things that multiply to get this number. 5 is 1 right here. 1 times 5 gets 5. But I skipped 4 in here. Well, 4 is not just 1 and 4. 4 is 1 times 4, but it's also 2 times 2. So if you have something where you have multiple things that multiply to get it, like different options, that is not a prime number. 7 is a prime number. 9 is not, even though it's odd. A lot of times, odd numbers are a good sign. That's it's going to be odd past 2 if it's prime. But 11 will be your next one, because 11 times 1 is the only way to get 11. Right there. 13 would be 1. 17 would be the next one. So these are prime numbers. A lot of times you think about breaking things down into these numbers when you're trying to factor something. So, if you're factoring 24, like this term right here on the side, there are a few different ways you can approach this. A lot of times when you're first learning about factoring, you'll do something called a factor tree, where you say, okay, well, what's a prime number? Like over here, what's a prime number I can break out of 24? Well, I can break 24 into 3 and 8 right there. So we have one prime number right here on the outside, but 8 is not prime, because 8 is 1 times 8 and 2 times 4. So there are multiple things you can multiply to get 8. But yeah, 8 is 2 and 4. That 2 is a prime number. So I can break 8 down into 2, and then 4, which is not prime. But 4 breaks down into 2 2's. So if you look here, 24 is made by doing, the 24 is basically equal to 3 multiplied by 2 3 times. So you could basically write this in a shorter way of doing 2 to the third right there. So 24 can be found by doing 3 multiplied by 2, multiplied by 2, multiplied by 2. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So you can see that verifies that is 24. Now, eventually we're going to have stuff that has variables in it as well. And you'll do something similar to something like this. The only new thing here, the 60, you can do with a factor tree. But the x squared, y squared, basically what that's going to look like when you break this down. So 60 is a 6, which is 2 and a 3, times 10, which 10 is 2 and 5. So there's what 60 breaks down into. But x squared is x and x. Okay, and then y to the 5th would be like 5 y's. So this would be kind of your factorization of that right there, drawn out. And then of course you can make the number parts be a little bit cleaner. 2 to the 2nd times 3 times 5, and then x, y, 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 y. And the other reason I'm writing this expanded kind of like this is we're going to do something with this in just a second with the GCF. But to kind of show you where this is going, so, in the last section, we were able to multiply like x plus 2 and x plus 3. I showed y'all kind of how to do something like this where you distribute your x. That gives you x squared and 3x right there, x squared plus 3x. And then you also distribute your 2 to both of these things. You end up getting a 2x and a 6 right there. Well, when you combine all the like terms here, you get x squared plus 5x plus 6. Or essentially, where we're wanting to go is we're wanting to take this right here and take it back into a factored form of x plus 2, x plus 3. So this is kind of showing you where we would be going with this chapter, with this section anyway. Well, it actually is until the next section after this where we start doing a trinomial, but eventually that's where we're going to be going toward once we get our factoring kind of worked up. So to start out our conversation about factoring, we do want to show you or mention something called the greatest common factor, or the GCF. So the greatest common factor is basically the largest number that divides evenly into every single term that you're looking at. So, for instance, let's say that you're looking at 9 and 21 right here. Well, we know that 9 is made of 2 3's in it. And 21, it is made of a 3 and a 7. Well, the GCF is the largest factor that they have in common, or set of factors, I guess. Well, this in this case, we can see that both 9 and 21 share a 3 in common, so the GCF for this particular problem would end up being 3. Okay, if you have 3 numbers like 15, 30, 45, you do the same thing. You can break each one of them down. 30 is 2 times 15, which we already know 15 is 3 and 5. And then 45, I know 9 goes into 45. 9 is 3 and 3 right there. 9 times 5 right there. So if you look, the GCF of this would be, there'd be a 3 in it, and there would be a 5 in it. Everything has a 3 and a 5 in common. So the GCF for these 3 numbers would be 15. And like I said, if you have trouble doing 45, definitely make sure you do on the side. You could do it like I did, where I said 9 times 5. Well, I know 5 is prime. 9 is 3 and 3. So you could always do the breakdown on the side in a factor tree if you get stuck on something. Or just use your calculator. I would definitely suggest, if you're not very good with the multiplication, to lean to using your calculator, just so you can not have to worry about the barrier of having to learn about GCF and having to try to learn multiplication rules. So but yeah, let's look at the GCF here, where it has 12x squared and 36x. So if I break down 12x squared, that's going to be 12 is 3 times 4, which 4 is 2 and 2. So 3 times 4 will give me 12, and then I have x and x as my variable. And then 36x, well, that's going to be 36 is 3 times 12. So 3 and 12. 12 is 3 and 4, which 4 is 2 and 2. So that one definitely, 36 might be one where you definitely need to go to your factor tree and just pull it out to the side. You can just have your little side work where you say, okay, here's 36. And we'll break 36 up into 3 and 12. 12 up into 3 and 4. 4 is 2 and 2. So you can break it up on the side if you need to. Now we just want to figure out what's all in common. Well, I like to circle what's in common. I do see I have a 3 in common. I do see I have a 2 in common. Another 2 in common. And there's an x in common. So I'm going to have a 3, a 2, and an x in common. So 3 times 4 basically is going to be 12x. And some of these you can just look at. Some of y'all may be familiar enough where you can just look at the two numbers and be like, hey, I know that's going to be 12 right off the bat. Some numbers end up getting a little bit bigger and more challenging. So you can always go to this method if you get like lost or you feel like the numbers are too big for you to multiply in your head. But let's do another example of this. We have 50y squared and 25y to the fifth. So 50y squared. 50 is 5 times 10. 10 is 2 and 5. Right there. And then y times y is y squared. Okay, and then 20y to the fifth. 20y to the fifth. 20 is 4. So 4 times 5. And then there's 5 y's. Okay, so the GCF of this, what's going to happen here is we got a 2 in common, a 5 in common, and a couple of y's in common. So that's going to be 2, 5, y, and y in common. So nothing else is in common that we see in both things. So what we're going to have here is 10y to the second as our GCF right here. So 10, 2 times 5 is 10, y raised to the second power right there. Okay? One thing I want to connect with you is if you look at the original problem, the original two things. So up here we had y to the second and y to the fifth. Well, think about for a moment how many y's made it to our GCF. Well, if you see, it was the second power. The two of them made it to the GCF. So this might give you an idea, like a rule in your mind that's going to happen for the GCF, but it's always going to be your lowest power of variable that makes it to the GCF, because the least number of them is going to be what's in common right there. We had 2 y's in common, so least power variable will be in the GCF. And you can see that happen on the one while ago as well. The one where it's like 12x to the second and 36x to the first. Well, if you look at our GCF, it was x to the first power that made it down here. So we didn't have to worry about, if you know that little trick, kind of, you can maybe jump ahead as far as the variables go for what you're looking at. So, like, look at this example here, where it has like 3 terms, like 8x to the xy to the fourth, 20x squared y to the fourth, and 28xy cubed. So on this one right here, we already know like the lowest x will be x to the first, because x to the first is on the 8 and the 28. Like, it's on those two terms beside them. So x to the first will be your lowest x, your lowest y. We see y to the third on the very far end in that last term. So y to the third will be the lowest y. And now we just need to figure out the GCF for the number part. The number part, 8 is 2 times 2. That's 4 times 2. 20 is 10 times 2. 10 is 2 and 5. And times 2. So 10 times 2, and then 28. Did we break that one down somewhere else? I don't think we did. So 28 is 4 and 7. 2 times 2, that's 4 times 7. The GCF of these numbers, so we have 2 2's in common. Or sorry. We have 2's in common. We have another set of 2's that are in common. So the GCF of the numbers is going to be 2 times 2, or 4. And some of you might be able to look at that easily and tell. So when we put these two things right here together, the GCF overall will be 4y to the third. Okay. So figuring out how to do the GCF is probably step 1 to kind of figuring out how to factor some of these polynomials. that we are going to be encountering. So go down a little bit further, and you're going to see where it says, okay, take an expression and factor out the GCF for that expression. And we may fill in some new examples too as we go down further. But if you see right here, this first one where it has a here, it has 9b squared and 6. Now, of course, you can go over on the side and kind of do what we did before, where you break down the 9, where you break down the 6, and then you figure out what the GCF is going to be. Well, the GCF of this, you see that there's going to be a 3 and a 3 in common. So the GCF overall will end up being 3 for this. But it says factor the following by factoring out the GCF. When you want to factor an expression, so you're breaking it down into something it was before it got multiplied, okay? You're going to do it like this right here. The GCF will be on the outside. And then inside a set of parentheses right beside it will be kind of what is left over when you divide out the GCF. So we know that a 3 is going to be here, like beside, like it's going to be factored out. And then we need to figure out, okay, when you divide 3 out of 9b squared, what is going to be left behind? When you divide 3 out of 6, what is going to be left behind? Well, if we reduce this, so let's simplify this a little bit. What we end up getting here is 3. This is 3b squared plus 2. That right there will end up being how you factor out the GCF from an expression right here. So the final answer for this problem will be the GCF on the outside, and then kind of what's left over. So your GCF is on the outside, and the leftover stuff is right here. Okay, look at B, the one just right below it. We have 7x squared, 14x to the third. If you look between 7x squared and 14x to the third, we know that like there's going to be a 7 involved with both of those. And the lowest power of the x's is x to the second. So we're going to have 7 in common and x to the second as your lowest variable power. So we need to figure out how to factor this so that 7x squared is on the very outside. Okay, so whenever you break this down, I'm going to rewrite this problem on the next line here just to make it a little bit easier to follow this. But on the outside, you're going to have 7x squared, and then on the inside of a set of parentheses is going to be what's left behind when you divide 7x squared out of each term. So I want to take 7x squared, divide it by that GCF of 7x squared. Then I want to take 14x cubed and divide it by 7x squared as well. And then what you do is just reduce that. A lot of times I think about it in my head like what's going to happen when I factor 7x squared out of 7x squared. Well, that's just going to be 1 because 7x squared divided by 7x squared is 1 plus 14 divided by 7 is 2 and x cubed divided by x squared will be x by itself. So this will be what you get when you factor out the GCF of an expression. You'll have the GCF on the very outside, and then inside a set of parentheses will be kind of what's left behind. And you can always, if you ever feel like, okay, I don't know what I'm doing, and I don't know if I'm doing this right, you can check it by multiplying. So you can always check your solution by multiplying, just like we talked about in the last section. So you take 7x squared and distribute it to the 1. You take 7x squared and distribute it to the 2x. Well, if you look, 7x squared times 1 is 7x squared. 7x squared times 2x, 7 and 2 make 14. x2 and x make x3. And if you look here, that what you got was your original problem of up there. So if you did it right, you should have them looking the same when you go to check your solution. Okay, so just something to keep in mind if you want to check it. Let's do another few examples here, just to kind of, the more practice you do on these, the better you're going to be, especially if you're just starting out factoring, or you're fuzzy on your dividing. So this one we have 24 and 12. I definitely know GCF wise that 4 is the largest number that will go into all three of these. And if you look, there's a y term on every single term that's here. So we have 3 terms. We have a term here, we have a term here, and a term here. So there's 3 terms here, and if you look, we have a y variable on every single term involved here. So it's going to be your lowest power of y's that makes it to the GCF, which in our case will be y to the second. So we know that when this factors, it's going to factor into something that's 4y squared on the very, very outside of your parentheses. So let's see. I'm just going to rewrite this here on the next line. I know 4y squared will be my outer term. And remember, you're going to basically divide each term by 4y squared. Well, when I divide this 20 by 4y squared, so I'll just kind of write it underneath to kind of think about it in my head. So right here, 20 divided by 4 will be 5. Left over, y squared divided by y will be, there's no y's. Okay? Then I bring my minus sign. This minus sign right here, just bring it right over. Okay, next will be, I want to divide 4y cubed by the GCF 4y squared, because I'm trying to factor it out. I know when I divide 4 and 4 by each other, that'll end up being just 1. Y cubed divided by y squared will leave behind y to the first power, or just a y. Okay. Then I want to bring over my plus sign right here. So bring right over your plus sign. Okay. Then we want to divide that 12y to the fourth by 4y squared. Well, 12, when you divide it by 4, you get a 3. Y to the fourth divided by y to the second. So basically, it's like you're yoinking 2 y's out. You're going to have 2 y's left behind when you factor out. You bring out that y to the second right there. So when you factor this will end up being what you have as your answer. So the stuff that's here in red is kind of like I'm thinking about this stuff, like I'm dividing each one by 4y to the fourth right here. So I just kind of wrote it underneath to have you think about that. But the final answer is going to be this right here, where we have 4y to the second, and then in parentheses 5 minus 1y, or just y, plus 3y squared. So that'll be your final answer for factoring this particular trinomial. Look down at the D problem right there, and don't forget you can check these by multiplying, and that'll end up helping you out as far as seeing the connection between factoring and multiplying. So down here on D part, we have 3z and 21 xz to the fourth. Now, if you're looking at 3z, that's just 3 times z. 21 xz4, that's going to be 7 times 3 x, and then a bunch of z's. Now, I do see that it's in common is a 3 in common, and then 1 z is in common. So I see my GCF is going to be 3z. So no x's are in common because there's no x in 3z. So only 3z is my GCF. So that's what I want to factor out. So I have 3z minus 21xz4. I know that when I factor this, it's going to be 3z on the outside. And then inside, once I factor this, let me write this on a new line here. So I want to factor this. So I'm going to factor out the GCF. 3z is on the outside. And then inside, well, 3z, when you factor out, when you divide, oh, sorry, I zoomed in too far or something. Let me scroll back down just real quick. When you divide 3z by 3z, that is going to end up being 1. So I want to take my GCF of 3z and divide it into 3z to figure out what I'm going to get for my first number right here. Well, 3z divided by 3z, that'll end up being just a 1 factor right here. And then let's bring my minus sign, this minus sign, just bring it down right here. And then I want to divide 21 xz by 3z. So what I end up getting here is a 7. Z and Z4 cancel, leaving 3 z's. But what else am I going to have? Well, I'm also going to have an x because there was no x's that canceled out. So if you look back over here, 3 and 21 cancel, make 7. Z and Z4 cancel, so it gives you 3z, but there's still an x that's still hanging around. So your final answer for this problem will look like this right here. And like I said, this part right here that I've done in red, this is kind of like just my thought process, the stuff I'm doing in my mind, but you're basically dividing out your GCF from each particular term right there. So what I have circled here will be your final answer. And you can obviously just clean it up a little bit. There's not really, I'm just going to write it a little bit cleaner here. But it'll be 1 minus 7xz cubed right there. Okay. Let's see. Go up to the other column. Just up here where it says part E over here. So looking at this one right here, so I have 6, which if you take 6, it's 2 and 3. So yeah, and then 7 is 7. Like 7, you really can't do anything with it. You can't break it down any further, because it's 7 and 1, and you know 1 goes into everything. So this right here, there is no GCF thing that's in common. So nothing other than 1, you know, and one's a common factor for everything. So usually we don't count it as far as a factor goes. So there's none, we're going to say, for this. So this right here, you know, other than 1, right? Other than 1. If you think back to what we talked about just earlier, whenever 1 is the only thing that, you know, you can multiply to get something, or to divide into something, right? Do you remember what we mentioned that was when it's only 1 times itself is what gets it? Well, this right here is prime. It's a prime term, or a prime polynomial, because there's nothing you can factor out of this polynomial other than 1 itself. Okay, 1 and itself. So this right here would be prime. Right here is what you would say. Okay. Look at F, where it has like 3 different terms. So for numbers, okay. So this one starts with a negative. I'm going to show you a couple of different ways that you can factor this one, because sometimes it'll say on the homework, if it starts with a negative, it'll say factor a negative out or something like that. Factor a negative GCF. You can do that. You can also factor a non-negative GCF. So I'm going to show you 2 ways to factor this. So GCF, if we let the GCF be positive 2, because 2 goes into 2, 4, and 10 all. As far as x's go, there is no x in common in the third term, 10y, but there is a y in common with everything. So I can say, let's let the GCF be 2y. Okay. Well, when I break this down, we're going to have 2y on the outside, And then inside we're going to have negative x squared. So when you factor 2y out of this y cancels, this 2 cancels. You're still going to have this negative sign and an x squared right there. So that's what's going to happen with that. And then I'm going to bring my negative sign that's right here. I'm going to bring that just straight down. And then I want to do the same thing for the next one. 2 and a y makes this 4 divided by 2 is 2. The y's cancel, but x is still there. And then last, bring that positive sign down. 10 divided by 2 is 5. The y's cancel out, so you'll get this. So this is factored with the positive GCF. So can you factor it with another? Is there another way to factor this? Well, another way you could factor this is take your original problem, so negative 2x x squared y minus 4xy plus 10y, and factor out a GCF that is a negative, in this case, negative 2y. So when you factor out the negative 2, here's basically what's going to happen when you factor this down below. So we're going to have the negative 2y setting out to the very front, but you've got to think about you're dividing each of these terms now by negative 2y. Well, what's going to happen to the signs of these? In that first one, when you look at the signs of the first two, these negatives right here are going to end up canceling each other out. So 2 divided by 2 is 1, and then there's still going to be an x squared left behind. So notice how when we did it the first way up here and the way down here, the signs are different. They changed. So you're going to see that in some other places too. But keep going. So this next one, we're going to have if you look right here, a negative 4 divided by a negative 2. When you have two negatives that are being divided by each other, that actually ends up being a positive number. So our answer will be positive 2. The y's cancel out, so no more y, but you'll have an x. 10 divided by negative 2 gives you negative 5 right there, and the y's cancel out. So this would be factored out with a negative GCF. So you can actually factor a positive or a negative GCF. And a lot of times they're not going to ask you to factor out a negative GCF. Only when the problem itself begins with a negative, generally would you probably think to do that. A lot of times you're not going to have to worry about that so much. But this particular problem was one that definitely they will say, make sure to have your GCF be a negative. And you can actually factor a negative out of anything. So some of the ones we did a while ago, you could factor a negative out. You just got to remember to change the signs of the inside, because they're just going to have the opposite signs at that point. Because you want to make sure when you multiply back in, everything is like it was in the beginning. Now look at the one down here on G part. G part, it has 3a and 5ya going on. So on this one right here, I see that there's an a in common with my problem. So I want to factor out an a, and then right beside this will be a 3 and a 5y, because I want to basically extract the a from each of those terms. 3 and 5 don't have anything in common. So this would be your factorization of that right there. And honestly, I should be writing just the equal sign with it right beside. So this right here is equal to a times, and then parentheses, 3 plus 5y. And you could distribute the a to see what's going to happen. Now, the reason I put this problem here, so this one kind of a little easier than some of the other ones we just finished. But if you look, see how this was like 3 times something. And this was 5y times something right here. Well, imagine this, instead of a beside 3, it was like x plus 7 beside 3. And beside 5y, it had like x plus 7 beside it. Something like this. Could you yourself, now seeing that up there factored, factor something that looks like this? Well, you definitely see that the 3 is here. There's a 5y here. There's a lot of stuff that's similar. The only thing they changed was the a, they replaced it with x plus 7. Your factorization is going to be the exact same as what we had up there. The only difference is, instead of a being factored out, you're now going to factor out this x plus 7 is your GCF. So your GCF is x plus 7. That's in common. So the GCF is right there. And then left behind, will be a 3 and a 5y. So 3 plus 5y. So almost the exact same as that previous problem, just it looks a little different from what you're used to. So try that with this problem down here. I'm going to put one thing down here in the I problem that you kind of don't see, but I'm going to put a 1 in front of this second one right here. But look what we have here. We have x plus 1, x plus 1 right here. That is a GCF. So that's going to be in common. X plus 1 factored out. And then left behind will be a 4x. So here's that 4x right there coming over. And then we have a minus sign that needs to come over. So I'm just going to drop it right here in the middle. Okay. And then there's a 1. So minus, when you factor all of something out, there'll be a 1 left behind right there, minus 1. Okay. That will be how you factor something that looks a little different. There's at least a couple of those on your homework right there. But they kind of lead into the end of the section, which is factoring by grouping. And once you have mastered doing the GCF factoring, this is the point where you're kind of ready to do factoring by grouping. Now, if you look at the problems down below here, each of these have 1, 2, 3, 4 terms. If you ever have a polynomial that has 4 terms, a lot of times how you're going to tackle that is trying something called factoring by grouping. So factoring by grouping, the way it generally works is we're going to group our sets of terms together and then factor the GCF out of each grouping of terms. And the last step is finish the factoring out. And you'll see, well, it looks very similar to something we just did once we get to that stage right there. Okay, but this will be great for practicing your GCF factoring because, you're going to be doing that quite a lot for each of these problems. So go down to this part A, number A, where it says xy minus 5y plus 3x minus 15. So what we want to start is, like, step 1 is kind of group your terms. So we're going to say step 1. I'll write out the steps here. We want to group terms. So we'll do kind of a step-by-step approach here. And when I say group, what I mean is we want to do our first 2 terms together. I usually use parentheses to group them. And then our second 2 terms. Okay. If there ever happened to be a negative on my second set, like minus 3x, I'd put the negative in the second grouping. But this one's just a plus, so I'm going to leave it like this right here. Now, the second step is to find the GCF of each grouping. So step 2 is find the GCF of each group. And then we're going to factor it out. So we want to basically find our GCF for each of our little groupings, and then we're going to factor or extract the GCF from each group. So I'm going to say this first little grouping right here, if you look, we have xy minus 5y. Well, there is a common factor of a y that's going on right there. So that is essentially what I want to factor out in front of my parentheses, and then left behind, well, after I pull the y away, will be an x by itself and a minus 5 by itself. So the y comes out front, and then the x and the minus 5 are left behind. Do the same thing for your other grouping. We're going to see what the GCF is of this. Well, 3x and 15, 3 and 15 may have a 3 that will divide into both of those evenly. There's no variable that's in common because 15 doesn't have an x with it or anything. So there's no x's in common. So it's just going to be 3. So I want to pull the 3 out. It is positive 3. And what's left behind will be an x by itself minus 3 goes into 15. 5 times. You can divide that on a calculator if you need to. And this is what we have. Now, the very last step is we're going to finish the factoring. Finish factoring. Well, if you look here, look at what you have. You have x minus 5, x minus 5. That is a common factor. So we're going to factor out the x minus 5, and then left behind will be a y plus 3. And that is how you factor a polynomial by grouping right there. Okay. We're going to do a few more examples because you really have to practice the steps so you can get used to seeing the factoring by grouping, step-by-step approach. But this is what you want to end up doing as far as when you have 4 different terms and it says factor by grouping. This will be the method. So go down to the next problem, B problem, where it says, just right here, we have y cubed plus 6y squared plus 4y plus 24. So my first step is I want to group my terms together. I want to group terms in sets of 2. So basically you're going to have the first 2 grouped together. And then you're going to have the second 2 grouped together. Then what we want to do next is find the GCF of each group. So find GCF of each group. Okay. Definitely something you'll want to practice right here. But this will be the GCF of these 2 right here will be y to the second. The GCF of 4 and 24 is just 4. Because 4 goes into 4y. 4 goes into 24. So I know that that'll be 4 that goes into both of those. And you can honestly do those out to the side. I haven't been doing them. But if you really need to go back to what we did before, where you break down each on the side, you can definitely do that. 24 is 2 times 2 times 2 times 3. So you can see there are 2 4s, there are 2 2s that are in common. So that means 4 is our GCF. So you could do any of this on the side, like we did in the earlier in the chapter. But now what we want to do is factor the GCF out of each part. Y squared. When you factor y squared out of y to the third, well, that's going to be y squared pulled out. That means y to the first will be left behind. And then plus 6, because y squared is joint to the outside. So that's the GCF. So it'll be just 6 by itself. Plus, this is the plus sign. I just brought this plus sign down right there. And now my GCF is 4. 4. I want to extract that from 4y. Well, that'll be just y left over. Plus 6 right there. Now, if you did the grouping right, you will notice that you're going to have terms that are like each other at this stage right here. Okay, so that is, that's one way you can tell. Okay, yeah, this. That's one way you can tell if this does factor or you factored it right, right there. All the homework problems that y'all have are going to end up working like this. Now, if you ever had it to where maybe these didn't look alike, you could rearrange your middle terms and try to factor it again to see if it factors. There are cases where 4-term things will be prime. There's none of them on your homework though. So all the ones on your homework do break down. But if you're looking at this right here, we see that we have y squared times y plus 6, and then 4 times y plus 6. We want to factor out y plus 6. This is the last step, is finish the factoring. So we want to finish y plus 6, and then y squared plus 4. Okay, and that is the very, very end of the problem right there. I have a couple more that we're going to practice, and then you'll pretty much have all the examples you need to probably go at trying some of the homework problems. But we'll try a couple more. The ones that have minus signs in it are the ones I really want to hit next. So go up to C where it has some more minus signs going on here. Now, let's start by grouping these. So we want to group these right here, and then we want to group these. Now on this second grouping, I want to show you how I'm going to write the parentheses for this. So when I group the first set, nothing new happens with that set. But when you group the second set, you need to make sure the negative is inside the parentheses. So that's generally how I do these ones that have negative. Group negative sign with that second set, with in this case, the 2n squared. So the negative goes with that 2n squared. Now, the next step is getting the GCF of each grouping. Nothing is really going to change for this. This first set right here, I see that I have m to the second in common with both of those. There's no n's in common with the second one, so it'll just be m to the second. With this one right here, though, my GCF is actually going to be a negative 2. So if it starts with a negative, it's best to often factor out a negative GCF. If it starts with a negative, we want to factor a negative GCF. Okay, so when you break this down a little bit further, we have m to the second, n squared plus 1. And then over here, so that one's not anything new, but when we factor this negative 2 out, this is your negative 2 GCF right here. So there's that GCF right there. And then left behind will be what's going to be left over inside. Well, when you factor the negative 2 away from negative 2n squared, negative 2 divided into negative 2n squared will be just n squared right there. So you're going to have positive n squared, not negative, because the negative 2 basically canceled out the negative. And then negative 2 right here divided by negative 2, the GCF, will be positive 1. So your final answer will be n squared, or your final factoring right here in step 2 will end up being just negative 2 on the outside, n squared plus 1 on the inside. Now, the way you know you did the signs right is if you look, you match. So if you didn't match the signs up, if you didn't factor out a negative 2, these would not actually match up. So you wouldn't be able to go any further. But if you did it right, if you put the negative where it needs to go, you're going to see that you can factor one last stage. N squared plus 1 comes out front. And then left behind will be m squared minus 2. as your final answer. And you can always multiply this out to check it. You know, it's a lot to multiply out, but when you multiply it out, you should get back to your original problem up here when you multiply it all back out to check the answer. Okay, and these are definitely a little bit more complicated with the negative signs. So go down to one more. We'll practice one more real quick. Here's one where we have some more negatives. Now, another thing you could do if you wanted to avoid the negatives is you could honestly change, like, you know, swap these, like swap their placement and then factor it so you can avoid the negative stuff. Sometimes I'll do that in practice. That way I don't have to worry about factoring a negative out. But we'll show you the way to do it without doing that. So I'm going to put these first two terms in a set of parentheses and then plus, and then I'm going to put the second two terms in its own set of parentheses. So we want to group our terms. So step 1, we group. Step 2, we figure out the GCF. And hopefully by the point, once you practice enough homework, you're going to be able to easily tell what the GCF of each set of parentheses is going to be. This first set has an X that's in common here, so I know there's an X that's going to be there. And then there's nothing else really, just an X. So when you factor out an X for that first set, you'll have X. When you take X away from XY, there's just a Y left behind, a plus sign. When you take X away from 2X, there's just a 2 left behind. Okay, so there's that one right there. Okay, and then I'll bring my plus sign down. And then over here, this GCF. So this one has a negative as a GCF, like -1. So there's not really anything else you can factor out other than a -1. So there's nothing else that goes in common variable-wise. So we're going to factor out a -1, which means instead of making it, you know, positive down here, you can just make it -1, and then this will be y plus 2 right there. So yeah, you could write it like I wrote it, or a better way to write it, a little cleaner way to write it, would just look like this right here. And now we can finish the factoring. We'll have y plus 2, x minus 1. And these definitely take some practice to work out, especially when you have the negatives. If you wanted to avoid the negative altogether, you honestly could rearrange your problem to where it was like x, y minus y plus 2x minus 2. So you could also take your original problem where the minus y and the 2x were, swap them, swap the middle two terms, just add them in a different order, and then when you group these, so here's the GCF of this would be y now, so you have a y GCF, so that'd be y, the x minus 1 will be left behind. When you factor out the GCF here, the GCF of this would be 2. Now you have positive 2 as your GCF. X minus 1 will be left behind. And then, look, there's x minus 1 in common. Y plus 2 is left over. So you can do it this way too, and you get the exact same answer right there. Remember, it doesn't matter what order you add in. You can, or what order you multiply in, you get the same answer. So those two answers are identical to each other right there. So just keep that in mind. You could do it another way if you wanted to with your notes. So this is like another way to do it. That way you don't have to worry about factoring out negative signs. But there are multiple ways to do these. They definitely take practice. I'll leave you off with that, and then hopefully if you have questions, you can just text me or message me with any problems that you need help with.